Alright, here are your video notes for solving rational functions. We're going to walk through number 1, number 3, and number 7. And then the rest of them are going to be up to you to solve and then check your answers that are provided to make sure you're going to be ready for tomorrow's assessment. This will be the last learning target for the unit. So looking at problem number 1 here, one method we used in class would be to find for each one of the fractions a common denominator. In this case, our common denominator is going to be 6p. So we'd have to multiply each fraction on top and bottom by whatever it needs to make sure that it has 6p. So in this case, I just have to multiply the bottom by 3. So I have to multiply both top and bottom by 3. And keep in mind, when I simplify on top, I'm going to have to distribute that 3 to both the p and the 3. For the 1/2 on top and bottom, I'll have to multiply it by 3p because that'll give me 6p. So on top, I'll also have to multiply by 3p. And for the 1/6, I'll just have to multiply here by p, so it already has the 6. So now if I rewrite my function, we'll have 1p over 6p equals 3p over 6p plus, now distributing that 3, I will have 3p plus 9 all over 6p. So now that we have a common denominator, the only thing we need to focus on here is going to be the numerators. So now we can just say p has to equal 3p plus 3p plus 9. And I'm solving this linear equation. So 3p plus 3p would give me 6p plus 9. I'm going to subtract 6p over to the left side. Now we'll have negative 5p equals positive 9. Divide by negative 5, and I'll have p equals 9 over negative 5. And now looking at number 3, here is going to be a little more complicated. I can't really see for two of these ratios or two of these fractions what factors I actually have on the bottom. I know I have a whole p plus 5 on the left, but what we can do is we can take both of these quadratics, which are the same quadratic, and we can write it in factored form. So if we rewrite it in factored form using my area model, I know that this has to be p squared, this would have to be 2p, and then the sum of this rectangle would have to be negative 15. So this would have to be p squared, and this would have to be negative 15, which means these lengths would both have to be p. And now it's up to me to find these lengths to multiply to negative 15, but make sure that the sum of these two rectangles has to give me a positive 2p. So let's try 5 and negative 3. That'll give me 5p. This will give me negative 3p. If I add them together, I'll get my 2p. So now I know that my factors are p plus 5 and p subtract 3 for both of these. So it looks like I actually have a common denominator here on the fractions on the right. And now you can see that on the left side, I would just need to give this a factor of p subtract 3 on top and bottom. So now all my fractions have the same common denominator, and I can just worry about what I have on top. So doing that, I'm going to multiply the 5 into the parentheses, and I'll get 5p take away 3, and that has to equal p. And don't forget about this subtraction symbol here. subtract 5. And now here's the equation that I'm going to solve. Subtract p to get 4p minus 3 equals negative 5. Add 3. I'll have 4p equals 8. And then divide by 4, so I get p equals 2. Now, every time we solve here, we want to make sure that our answer is not going to be what's called an extraneous solution. That's whenever you input that value back into the original function, and if it's extraneous, it's going to give you a value of 0 in one of the fractions in the denominator. And we know we can't divide by 0, so that's why it's called an extraneous solution. In this case, if I put p equals 2 into any of the factors, I'm not going to get 0, so it's not an extraneous solution. And same for the first one. The only value for p that would give me 0 would be p equals 0. So I know my answer is not 0, so I don't need to worry about that. I don't have an extraneous solution. So now let's finally look at number 7. All right, in this case now, our greatest or our common denominator is going to be, well, I know I'm going to need an m squared because this has 2 m's, and then I can make everything 6. So 6m squared will be my common denominator. So 1/6 will need an m squared. I'll know that I need a 6 here, and then on top and bottom I'll have to multiply by another m to get m squared. So now I have m over 6m squared plus 6 over 6m squared equals 1m squared over 6m squared. So now I'm just going to worry about my numerators. It'll give me m plus 6 equals m squared. So now I don't have a linear equation. I have a quadratic equation because my degree is 2. And the only way I know how to solve quadratics is either using the quadratic formula, or I could factor, or I could solve this graphically. I'm going to choose to first set the equation equal to 0. Because then I can decide whether I want to use factoring, which could be an easy solution, or I can use quadratic formula. In this case, now I'll have 0 equals m squared minus m minus 6. I'm going to go ahead and try to factor. In this case, using my box method, I'll have m squared, I'll have negative m, and I would have negative 6. So I know that this would have to be m squared and negative 6, so m and m. And in this case, I want to make this negative 3 and positive 2. That would give me a negative 3m, positive 2m. Now if I add those up, I get a negative m there. So actually it's easily factorable. This is m minus 3, m plus 2, and this equals 0. So now I know by the zero product property that the only way this product can equal 0 is if the factor m minus 3 equals 0, or m plus 2 equals 0. And this is how we get m equals 3 and m equals negative 2. So we should check real quick to make sure that these values, m equals 3 and m equals negative 2, can be inputted back into the original function and not give me a problem. So negative 2 and positive 3 inputting back into the denominators here won't give me a value of 0, so I'm completely fine. Neither one is going to be extraneous. So there's a tutorial of 3 practice problems. I hope this helps in finding common denominators and solving your equations. Tomorrow we will be having an assessment on solving rational functions, and then we're going to go ahead and we're going to have a final test for the unit on Wednesday. All right, hope you enjoyed.